pleasure for me to meet you in the blended mode learning. In this class, we are going to study retrosynthetic analysis. The main learning objectives are what is retrosynthetic analysis. Then terminology used in the retrosynthetic analysis are target molecule, starting material, disconnection, synthon, synthetic equivalent, types of disconnection, one group disconnection, two group disconnection, disconnection rule. Next, what is retrosynthesis? Retrosynthesis is one of the synthetic methods. Here the synthetic steps are given in the reverse order. Retro means reverse. On simply saying it is a reverse synthetic route. Here the synthetic steps are given from product to reactant. The main application of this backward synthesis is to find the reactant for synthetic product. The terminology used in the retrosynthesis. Desired final product obtained in the retrosynthesis is called the target molecule. Reactant molecule used in the retrosynthesis is called the starting material. The conversion of target molecule into starting material by imaginary bond breaking is called a disconnection approach. It may be a real reaction. Those reactions are called a synthetic tool. The fragmented species obtained during disconnection are called a synthon, which are not available in the lab. The available molecule in the lab equivalent to the synthon is called a synthetic equivalent. What is retrosynthetic analysis? Explained with a suitable example. Retrosynthetic analysis is an empirical method. Here target molecule is converted into starting material either by imaginary bond breaking or by functional group interconversion. It can be explained by the following simple example. Here one organic molecule is taken. In that organic molecule there may be two functional groups. One is a carbonyl group, another one is a olefinic double bond. Both the ends are connected, both the end of these functional groups are connected by phenyl group. This olefinic double bond is a less reactive, therefore it should be converted into more reactive functional group. Therefore functional group addition to be done on the double bond. Here OH is added. Now the question is, OH is added to which carbon? Carbon connected to the phenyl group or carbon connected to the CO group. Here carbon connected to the phenyl group is having low electron density, therefore OH to be added. It's a correct one. OH is not connected to the carbon connected to the carbonyl group, that is having high electron density. When this molecule is subjected to disconnection, here carbon-carbon bond is broken. As a result, two ions are formed. One is negative ion, another one is a positive ion. These two ions are called synthon. The positive and negative ions obtained in the disconnection are called synthon. Then the negative ion, the equivalent molecules of the negative ion is acetophenone. The positive ion, the equivalent molecule of the positive ion is acetaldehyde. With the help of this above analysis, we can find the starting material. The obtained synthetic equivalents are the starting material. Acetophenone and benzaldehyde are obtained as starting material. They combine together only by aldol condensation from target molecule. They have the forward reaction. Acetophenone, benzaldehyde in the presence of base, it gives aldol. Then it eliminates 1 mole of water to give the target molecule. I will give another one example for retro analysis. Here butane is taken. Butane, it is a butane. In that butane is an alkane. Here no functional group in that molecule. It is also less reactive. Therefore, it should be converted into more reactive functional. It should have more reactive functional group. Therefore, functional group is added to this butane. Here OH is added. 2-butanol, it becomes FGA gives 2-butanol. Then it is subjected to disconnection. Carbon-carbon bond is disconnected. Here one of the fragment is ethyl minus ion. Ethyl negative ion is formed. Another one ion is having positive charge. The equivalent ethyl minus ion will be Grignard reagent. This Grignard reagent will give ethyl minus ion. Ethyl minus ion will be obtained from the Grignard reagent. Then The equivalent positive ion will be acetaldehyde. Equivalent positive ion will be acetaldehyde. When acetaldehyde is treated with the Grignard addition, it will give, followed by hydrolysis, it will give secondary butanol. Then secondary butanol is subjected to dehydration. It gives olefin. Followed by hydrogenation in the presence of nickel catalyst, you can get the butane. Then another one example is taken here. 1,5-diphenyl pentane 1-ol is taken. This molecule is subjected to retrosynthesis. We can get this desired product. We can get this starting material. Here various routes are available. We are going to find the various route one by one by doing disconnection approach. Here first in the first route, we are going to break the carbon having function. We are going to disconnect the carbon having OH group. When it is broken, two different types of synthons are formed. Then this type of synthons are the synthon formation is difficult. Then in the other case, carbon having positive charge, then another carbon is having negative charge. These two ions are possible. Here the equivalent molecule will be, one equivalent molecule will be benzaldehyde, another one will be a Grignard reagent. Due to the Grignard addition, you can get this target molecule. It is a one route, synthetic route. Another synthetic route is, here also we are going to break the functional group carrying carbon. Here phenyl group is broken, functional group carrying carbon is broken. This bond breaking is occur in between pH and CHOH. As a result, here also two different types of synthons are formed. Then this type of synthons are available. It will be possible. This kind of disconnection will be possible. Here equivalent molecule will be phenyl magnesium bromide and one aldehyde will be obtained. These two undergo Grignard addition. You can get this desired target molecule. It is the second synthetic route. Then third synthetic route is, we are going to disconnect the second carbon. Second and third carbon is broken, not in the functional group carbon. Here also epoxide is obtained as a synthetic equivalent. Another one is a Grignard reagent. These two undergo reaction to form this target molecule. Let us pass on to the fourth synthetic route. Here also we are going to break the second and third carbon. Here one equivalent molecule will be ketone, then another equivalent molecule will be halide. In the presence of base, it gives the target molecule. Then in the fifth route, here we are going to break the third and fourth carbon. Third and fourth carbon will be broken. As a result, here one compound having double bond, another one is a Gilman reagent. Here also, due to the reaction, we can get this desired product. Here, before obtaining the desired product, here the OH group is in the target molecule. The OH group present in the target molecule is converted into functional group interconversion by. Due to the functional group interconversion, this OH is converted into ketone. Then we are going to carry out the disconnection. Then for possible routes are, all the possible routes are given. A disconnection nearer carbon or disconnection at the carbon having functional group is not a better one. The functional group present in the carbon, nearer carbon is a better one. Here the first and the second route, we are going to break the functional group carrying carbon. Therefore, it is not a better one. Then in the third, fourth, fifth, we are breaking the carbon nearer to the carbon carrying functional group. 3, 4, 5. Here we are breaking the carbon which are having OH group nearer to this. This 4 and 5. Here one step is the carbon bond formation, next step is a functional group interconversion. Therefore here 2 steps are needed to convert the starting material into target molecule, whereas in the case of third route, the target molecule is converted into, starting material is converted into target molecule by only one step. Therefore the third route is a more opt route. Let us pass on to the next one. Types of disconnection. One group disconnection, two group disconnection. There are two different types of disconnection. What is one group disconnection? If the molecule is having one functional group, it will undergo bond breaking to give a synthetic equivalent. Such type of disconnection are called one group disconnection, or the molecule is having one or more functional group. During the bond breaking, one of the functional group is broken down into two fragments and the other is not affected. It is called one group disconnection. I will explain those things with one simple example. Here the molecule is having two functional group. One is a ketonic functional group, another one is a ether functional group. These are present in the benzene ring system. When this molecule is subjected to disconnection, here one of the functional group is broken. Among the two functional group, more reactive functional group is broken. Here carbonyl group is more reactive, therefore it will be broken. Among the two functional group, ether and carbonyl group is more reactive, therefore that functional group is broken during the disconnection. As a result, synthons are formed, then equivalent molecule will be acetyl chloride and methoxybenzene. When this acetyl chloride is treated with methoxybenzene, in the presence of anhydrous aluminum chloride, it gives the target molecule. When we break the bond, one of the functional group alone broken, other remain unchanged. Such type of disconnection is called one group disconnection. As a result, anisole and acetyl chloride are obtained as a synthetic equivalent. They combine together to form target molecule by Friedel-Crafts acylation. Then I will give some other example for one group disconnection. Here 2-butanone is taken. In the 2-butanone, we are going to break the carbon-carbonyl bond. As a result, you are going to get two fragments. One fragment methyl group is having negative charge. The equivalent molecule will be a Grignard reagent. Then another group is another fragment is acid that can be obtained from cyanide. These two combine together to get this ketone. It can be also explained with the help of another one example here, the tertiary butanol, tertiary alcohol. This tertiary alcohol is subjected to carbon-carbon bond breaking. You are going to get a CH3, CH2 minus, CH3, CH2 minus as one of the fragment. Another one fragment is having positive charge. Then the equivalent molecule will be CH3, CH2 minus will give the equivalent synthetic equivalent of CH3, CH2 minus is Grignard reagent. Then the synthetic equivalent of this positive ion is acetone. When this acetone is treated with the Grignard addition, you can get, followed by hydrolysis, you can get this tertiary alcohol. Here one of the functional group is broken during this disconnection. Let us pass on to the next one. Then headlines to disconnection. We should recognize the functional group present in the target molecule. That is the important thing. We should recognize the functional group in the target molecule. Then for compound consists of two parts joined by heteroatom. The disconnect next to the heteroatom, that is an important thing. Then disconnection next to the aromatic ring should not take priority. Disconnect reactive group first. Disconnection must correspond to known reliable reactions. Then two group disconnection. If the molecule has two functional groups, both the functional group will be broken down during the bond breaking. Such type of disconnections are called two-group disconnection. It may be classified into different types based on the position of the two functional group. If two functional groups are present in the first carbon, it will be called 1,1 difunctionalized. Example is ketol. Here the acetols are given. Here the two functional groups are present in one carbon. When you break this compound, when you break this bond, both the bonds are broken. Here 1,1 disconnection, 1,1 disconnection, both the bonds are broken. You can get this acetone as one of the synthetic equivalent. Another one synthetic equivalent is methanol. When acetone is treated with methanol, you can get this acetol. Then another one example is cyanohydrin. Here cyano group is also present in the same carbon and OH is also present in the same carbon. Therefore, it is an example for 1,1 difunctionalized compound. When it is subjected to 1,1 disconnection, both the bonds are broken. You are going to get cyanide ion is removed, Cn minus. Then you can get another synthetic equivalent is ketone. Another synthetic equivalent is ketone. When ketone is treated with the hydrogen cyanide, it undergoes nucleophilic addition. As a result of nucleophilic addition, you can get this cyanohydrin. Then another one example for 1,1 difunctionalized compound is amino acids. Here the amino group is also present in the same carbon as well as carboxylic group is also present in the same carbon. Due to the functional group interconversion, COOH is converted into cyanide. Then it is subjected to 1,1 disconnection. As a result of 1,1 disconnection, Cn minus ion is removed. Then it will be converted into the positive ion. Synthetic equivalent of the positive ion is acetone. When acetone is treated with hydrogen cyanide and ammonia, you can get this compound. Followed by hydrolysis, you can get this compound. Then 1,2 difunctionalized. Here the two functional groups are in the neighboring carbon. 1,3 difunctionalized. Two functional groups are in the 1 and 3rd position of the carbon, just like 1,4 and 1,5 difunctionalized. Here the first example is 1,5 difunctionalized. Ketone is present in the first carbon and ketone is present in the 5th carbon. It is 1,5 difunctionalized. We are going to break the 3rd carbon. Therefore, it is 1,3 disconnection. We are breaking the 3rd carbon. 1,3 disconnection. Then another molecule, another example, OH group is in the first carbon and NH is in the 2nd carbon. It's a 1,2 difunctionalized. 1,2 difunctionalized. Here also breaking the 2nd carbon. It is also 1,2 disconnection. 1,2 disconnection. Let us pass on to the next example. Here ketone, both the ketones are present in the adjacent carbon. 1,2 difunctionalized. It is also a 1,2 difunctionalized. 1,2 difunctionalized. When you break the, when you see this example, here breaking during the disconnection, both the functional groups are not affected. Both the functional groups, carbonyl groups are not affected. Therefore, it comes under one group disconnection. Methyl group is having minus charge and CO group is carbonyl carbon is having positive charge. Then synthetic equivalent will be in the positive carbonyl positive charge is connected with the Cl. Then methyl group is connected with the Grignard reagent. Then these two undergo Grignard addition. You can get this product. You can get this diketone. Here when you see the next one here, both the carbonyl groups are broken. Here two group disconnection. It is an example for two group disconnection. Let us pass on to the next one. Here it is an example for 1,3 difunctionalized. First carbon is having carbonyl group and third carbon is having OH group. 1,3 difunctionalized. One is ketone, another one is OH. Here OH is more reactive, therefore the OH carbon is broken. during the disconnection. Second carbon is broken. Therefore, it is 1,2 disconnection. 1,2 disconnection. Then in the next example, here you see the next example. Here, first carbon is having carbonyl group and third carbon is also having carbonyl group. It's a 1,3 difunctionalized compound, 1,3 difunctionalized. Here also breaking the second carbon, 1,2 disconnection. It is also an example for 1,2 disconnection. In the third one, first carbon is having carbonyl group and also in the fourth carbon is having carbonyl group, 1,4 difunctionalized. 1,4 difunctionalized. We are breaking the second carbon, 1,2 disconnection. We are carry out the 1,2 disconnection. You can get the 2 fragments. Here first carbon is having carbonyl group and also fifth carbon is having carbonyl group, 1,5 difunctionalized. 1,5 difunctionalized. Here we are breaking the third carbon. It is an example for 1,3 disconnection. In that way we can learn a lot of disconnection. Then let us pass on to the last part. So far we have learned what is retrosynthetic analysis, then terminology used in the retrosynthetic analysis, what is a disconnection approach, what are the different types of disconnection approach, one group disconnection, two group disconnection, then guidelines for disconnection. Then for our clarity, we can also go through the videos connected with this one.